Welcome, everyone. My name is Anand Jhingran. I used to be the CTO for a company called Apigee that some of you might know. We help some of you or many of you with APIs. But I have actually dabbled in data analytics and machine learning and other things longer than some of you at least have been on this planet Earth. So it's a fantastic thought process to see what's really going to happen or what's really happening when these two forces come together. And what we'll also do is kind of bring all of these topics and things and discussions that I kind of bring about with by bringing a customer over, Jason Smith from Armark Bio, who's going to talk about how he and his team bring the power of AI and API together. So if you're ready for the journey, let's go. I'm a very peripatetic individual, so my biggest fear is I'll fall. And so if you see me come close to the edge, just start screaming, and that'll be good. Okay, so this is the duality that we're going to discuss. Keep it at a high level. I'm a nerd, a geek, a technologist, but what I want to do is that for all of you to leave here today and understand that these two most powerful trends that are happening in the digital economy actually have a very, very symbiotic relationship. And what I want to do is kind of just get all of you to get comfortable with that symbiotic relationship. So in order to begin, I thought that kind of building upon what Feifei talked about yesterday, just give you folks a bit of a perspective on the AI journey that has happened and kind of contrast it with a couple of other things that are going on. Now, AI, of course, has been thought about for a long time as something that can act, pass a Turing test, and act and think like a human being. Now, of course, as for those of you who know, the test by itself is sometimes easy to pass and sometimes difficult. Some of you would have seen the movie called Ex Machina, where the entire premise was around the Turing test. But if you think about it, there was a computer program called ELIZA. Any of you have heard of the computer program called ELIZA in the 60s? Yes. And ELIZA proved to me once and for all that we paid too much when we paid to the psychiatrist, the $1,000 an hour. Because all ELIZA had to do on the other end was respond back with, if you said that you're feeling down, she would say, tell me why you're feeling down, and there goes your $1,000. So it did appear like a psychiatrist, but we know for all that she was actually not really doing much. The contrast with AI really is this concept of IA, which has had a much more profound impact in our existence. The concept of IA, or intelligence amplification, was brought about by the people who were doing cybernetics in 50s and 60s about machine and human interaction. And William Ross Ashby actually coined the term where he said that machines actually are there to amplify human intelligence, okay, as opposed to AI, whose goal it is to actually figure out whether machines can actually substitute human intelligence. And if you look at this entire IT spend, the revolution of IT over the last 40 years, a huge amount of it has been in terms of intelligence amplification as opposed to artificial intelligence. And what's happening is that the hype, whether it's the hype or whether it is the reality or whether it's the fear or what else it is of AI, tends to dominate the conversation. But really it is AI and IA that kind of go together. To kind of bring these things together, if you think about the Google car, the Waymo car is a car which says, doesn't even have a steering wheel. Does not even have a steering wheel. Whereas Tesla, on the other hand, is there supporting the human beings make better decisions. Keep that in mind as you kind of think through all of this discussion and technology when it comes to all of this. Now, what's interesting for us, some of us geeks out there, is irrespective of whether we talk about AI or whether we talk about IA, underneath all of it is machine learning. And what machine learning really is, it's all about bringing the power of machines to actually learn, and the three facets that the machines actually learn with. And Feifei brought out a fourth one called talent. but I'll ignore that for now. We are all extremely talented folks anyway, so that's a given. Uh, it's data. Computation is shown as a calculator. Don't know why, but and by the way, my favorite calculator is the HP calculator. Anybody who talks to me about any other calculator is not going to go anywhere with me. And then algorithms. So as you all think about the power of AI, IA, or machine learning, think about what is your currency that you have. Do you have access to data? Do you have access to computation? And do you have access to algorithms? And where you think that you may be falling a bit short, and if you really believe at the end of this talk that it's really, really important for AI to play a role in it, but you're falling short on one of these three dimensions, what is your strategy to actually kind of complement and build yourself around it? Now, in order for me to kind of connect AI and IA and APIs, I thought I'll take you through a journey of AI. And the best way to take a journey is when human beings want to pit themselves against machines. Not Eliza. And human beings have almost always decided, not always decided, have felt that one of the tasks that they want to compete with machines is in playing games. The rules are well defined. The winners and the losers are clearly known at the end. So why won't we play games? So what I'm going to do is kind of take you through a journey of AI and its technology through some games that humans, in the form of programming computation, have played with real human beings. So some of you remember Deep Blue. IBM's Deep Blue computer beat in the rematch Garry Kasparov. And some of you may have seen Gary's expressions. He was not pleased. He was not pleased. But in reality, people said this is the dawn of machine intelligence. No. No. This was really machine computation beating human intelligence. The rules of chess allowed the Deep Blue machine, I was at IBM at that time, to look far enough in advance and figure out what is kind of the optimal rules. So this was not machine intelligence. And then again, when I was at IBM, those of you remember IBM Watson playing against Ken Jennings and the other person and winning. And Ken Jennings at the end saying, I, for one, welcome my machine overlords. But for those of you who saw that, if you remember, Watson laid a giant turd at the end of the game. I don't know how many of you remember, but for all of you, I'll just kind of bring it out for you. The question was, name a US city whose largest airport is named after something that happened in a person, important person in World War II, and whose second largest airport is named after a battle in World War II. And guess what Watson came up with? Toronto. Now, it probably ascribed to an imperialistic vision of taking over the world and making Canada the 51st state or whatever it was. But you realize at that very moment that as intelligent as computers can get, they are as fallible as human beings. But what was interesting was that it was a step away from just computation to actually understanding language, and for those of you who love to play Jeopardy, understanding the subtlety and puns and everything else, and this was definitely an advancement. So we went from computation to some amount of intelligence. But what's really happening in this world today is that there's a whole ream of new machine learning and AI techniques that are coming about. And the most promising of them is what's called neural networks. And neural networks try to mimic human brains, even though human brains are made up of trillions of connections, whereas neural networks aren't, and therefore they can solve simpler problems. But what neural networks try to do is that there is an interconnectivity of uh, of computational bits, and you give it an input on one side, and you tell it what the output should be, and the network then learns by itself, right? And what it does, the kind of magic it does, the steepest gradient descent. I loved writing the Go program for a three-way neural network and everything else in order to kind of learn what the heck was going on. It kind of learns, and then when you give it something new, it is able to tell you that this is a cat. Now, this is in contrast with how machine intelligence worked in the past. Machine intelligence in the past might have you may have programmed a rule in the end which said, if that animal has whiskers and shows an attitude, then it's a cat. If an animal has whiskers and is very loving, then it's a dog, right? I'm neither a cat owner nor a dog owner, so I probably offended both, all sets of you. But the essential thing is that you are kind of building these rules, and those rules are phenomenal, except they really, really suck, right? You cannot build those rules. So in contrast, neural networks are like this brain of ours that some magic happens, and we are able to recognize that that's a chair, okay? And we are able to recognize who's a man and who's a woman. How we are doing that, we don't know. So in some ways, it is profoundly dissatisfying. Profoundly dissatisfying that this new branch of machine intelligence is not able to explain to us how it is reaching those conclusions. But it's also profoundly satisfying that it can actually solve a set of problems that you couldn't solve before. Neural networks have come a long, long way. They can recognize, obviously, vision, speech, complex constructs that we have showed, and languages and translations. But that's all very good, because what neural network says is that you give it a set of data. There are smart people that say this is a cat and this is a dog, and neural networks determine what's really going on. What if you don't know? What if you don't have the training set? What do you do? So there's a new branch of kind of machine intelligence, which is one of those branches is something called reinforcement learning, which says that throw the machine in the wild and let it actually figure out what's going on. And that is kind of the concept that was then used in the next game that machines beat human beings. And that was Go. And if you play that video, in the end, just like Gary Kasparov saying this, just like Ken Jennings saying we welcome our new overlords, the Go master was kind of, whoa, what is going on? Now, in this particular case, Go, I don't play Go, but Go is infinitely more complex than chess, and simple, deep computation does not solve the problem. And Google's DeepMind had to bring a set of reinforcement learning techniques in order to be able to beat the Go chess master. Now, quite recently, Go has won, machines have won on poker. Now, you would think that poker is easy. For those of you who are from India, we used to play we play a thing called Teen Patti. I can't play poker, so I don't know what poker is. But I'm assured that it is infinitely more complex than any game that we could have played in India. So, but a computer program called Libratus from CMU managed to beat the poker champion. And it had 3 levels of learning going on: standard programming, reinforcement learning based on what it was observing during the day, what the players were doing, and then kind of reprogramming at the night. So human beings have been able to program the machines to beat other human beings to play games. And there's been strong advancement that's going on. Right now, there are no machines that can program machines to beat human beings. So it's safe for us. We are all there. We actually help make all of these programs happen. But the advancements are happening based on these new classes of techniques that actually make a difference. Now, what that means is that beyond games, games are interesting, it's entertaining, it's us versus them, and we root for, depending on which side we are, we root for either machines or human beings. It's a phenomenal thing. But machine learning is making a huge difference in a lot of other areas. Feifei touched on it. In vision, machine learning is making a big difference. Now, what's very, very interesting about vision is that it is not just machine learning that makes a difference. A lot of advancements in IT happen when two or three forces kind of come together. And in this case, machine learning combined with sensors have actually helped really advance a lot of this. Robots are becoming much, much smarter. I don't know whether any of you have ever programmed in a programming language called Forth. Any raise of hands? That's it, the distinguished gentleman to my right. And Forth was really designed for helping kind of make moves, but human beings were completely in control, and here robots are kind of learning themselves. So the theme in all of this is that the intelligence has been used to power either some interesting games or some applications that kind of bring that intelligence to bear. The next very, very important trend that's happening, and the trend that even Feifei talked about yesterday, was this concept of democratization of AI. So AI was being built in the context of either applications that you didn't care about, like games, or applications that you cared about, like vision and Street View. But AI was being built in context of all of those applications. What Google, as an example here, has been doing is to kind of break that barrier between kind of machine intelligence and the applications, so that now the applications actually touch a lot more people. And this, the common term that's being kind of being brought about is this concept of democratization of AI. And this is the first place where APIs make a difference. The breaking of the barrier between an application and a capability below it happens through APIs. Okay, great. So that's what's really happening. So APIs are actually enabling these specialized algorithms to get embedded in a lot more applications. And this is where now, when you get to kind of the industrial age of AI, the impact will happen. So it is not just the intelligence and algorithms built bespoke, but intelligence and algorithms applied across the board that will make a difference. So to give you some examples, Google Photos is just absolutely fantastic. I have moved all my stuff to Google Photos. I don't have a dog out there, but we typically, when we are winding down Apigee, we wanted to create a workbook, a photo book, and I was able to kind of search through the photos based on finding people. Translation, machine translation is a very tough problem. Some of you might have seen the work that Jeff Dean and others did in order to get machine translation built on neural networks. And it has just been astounding how much progress machine translation has built. But how many of us really care about reading that original stuff in Italian or Latin and translating it into English? But if you now think about the application of you are traveling and you come across street signs and you come across subway signs, how do you actually ensure that the application that you're dealing with has been powered with intelligence? So the break from bespoke applications to taking intelligence and applying it everywhere is happening through APIs. Prabhakar talked about it. He had kind of raised the bar on the numbers. He said 1 in 8. I thought it was 1 in 10. But for those people who interact with me, know that at least 10% of the responses that they get from me are machine generated. Now, the great thing is they have no clue which one. They have no clue which one, but it's absolutely, it's mind-boggling how good machine intelligence. So this is another example of how machine intelligence has gotten democratized because now it is touching people everyday applications. Search, all of you use search. Search has phenomenal sets of inputs associated with it. When Larry and Sergey built out Google, they said that we are going to build search based on page rank so that it's not as important as to how you say you are good. It's how important how others say you are good. And page rank then turned out to be one of the fundamental disruptors. But over time, of course, that is not the only signal. And it turns out that applying machine intelligence and understanding user behavior and others have really, really helped improve the search technology. So the net of all of it is that we are reaching the era of not only advancements in AI, but taking those AI through APIs and applying it to applications that we all look, touch, and feel. And in that context, as for those of you who work in enterprises, think about the problems that you have today that would be better solved if you could actually take some amount of machine intelligence and power these classes of applications, right? So I'm not going to kind of walk you through all of it. All of you have ideas and thought process on what can be done. But things that you couldn't do can be done because of advancements in AI and the ability to couple that AI into the application through APIs. So the third part that I want to just kind of talk about is this is great. Google and IBM and others have done some innovation. What's that got to do with all of you? So the third major thing that I want to talk about is that what's really going on is that one aspect of democratization of AI is that the AI techniques are more easily available for everyone. So what Google has done, for example, it has put out this thing called TensorFlow. Those of you who want to kind of geekify on tensors, we can have a discussion afterwards, has put out this thing called TensorFlow so that all of you can actually leverage your smarts against some infrastructure that Google provides. But in addition, Google has started to provide not just these kind of raw building block capabilities, which are shown on the right, where you can actually take those raw building block capabilities and apply your talent and do the right things. But they've started to package these kind of building blocks with an API in front of them so that you don't have to worry about doing anything. So on the left, I've shown kind of these 4 building blocks. Translation, if you really care about translation, send it a piece of text through an API and it will come back translated. Vision, send it an image. Now just think about it. If you can send it an image, you may be able to actually figure out what the damage is for a particular property if you are in property insurance. Speech, the major trend towards creating interfaces on speech or just text understanding. So what's really happening is that this AI, which started off being driven by these applications which were somewhat esoteric, like playing games, to applications that required very tight connection with AI, those techniques are now starting to come out and be available for all of you in order to actually make a difference. So I've already kind of touched about on AI and APIs, but I want to just kind of give you somewhat further discussions on kind of this duality. So what we have talked about is how AI will be deeply affected by APIs, which is AI gets unleashed for the masses through APIs. Obviously, as I said, whether you take some machine intelligence, whether you write any of your machine intelligence, but if you really, really want to power the myriads of applications, then you need that gearbox. That's our gearbox for APIs. You need that gearbox that will take all of that intelligence and power your applications. Apigee has always been in the business of decoupling services with applications because you want to make sure that the innovation in the applications happens at a rate that is different than the innovation in the services below it. The innovation in AI happened by coupling of the applications and AI, and now with APIs, this barrier is breaking. But there is a second very, very fundamental thing that's happening, is that APIs are actually also the way in which data are flowing back to make these machine learning intelligence smarter. So this duality between intelligence, APIs to power applications based on that intelligence, and then APIs to deliver data back for those intelligence is that virtuous cycle that we actually see a lot happening. But that duality is also true. AI will deeply affect APIs. So for those of you who are writing APIs, you need to think through how AI will deeply affect the APIs that you're writing. So I'm going to spend a few minutes in kind of getting you to think about your world of APIs and to see how AI will actually make a difference there. So in order to do that, I'm going to actually blow past some assumptions that you have. And what I want to do is to get you a bit anxious and think through and say, oh my God, if the world is really different, how I've been thinking of APIs, how will I think about them differently? So as a first example, I've shown an industrial economy and a smokestack. Pardon me. But typically, many of you think of end consumers as your customers. What if you're wrong? What if, instead of you being at the center of the universe, where people come to you and get your services, the thing is completely flipped? What if the consumer is at the center of the universe and the consumer chooses to interact with you? In that case, when you're thinking about your world of interacting with that consumer, how would you embed intelligence into every interaction? Because the person chooses to come to you, you don't choose them. If that's the case, and there's a phenomenal piece of work by a person called Nir Eyal called the hook framework, how would you actually use intelligence to hook that person so that among all the time that she would spend with you, she actually gets most fun and most interactions with you? The world is not slowing down. It is kind of slowing down. I know this is true. It's actually true. We'll probably add about a minute to Earth's rotation in the next million years. But that's not sufficient to actually create more time. The world is not slowing down. Then how would you actually hook the people in order to actually do that? And that's where you've got to think about embedding AI into every piece of interaction that you do. And if you believe that you do the interaction through apps that are connected by APIs, you actually have to embed AI into every piece of interaction, into every API. What if you kept thinking that AI is for esoteric applications? What if you thought that AI is for games? What if you thought that AI is for diagnostics? All great things, but what if you thought that AI is actually not going to affect you in any deep way? But in reality, if it is the case that every application needs to become a learning application, if every application needs to actually adapt and learn, what if that's the case? The examples that I showed you, then you have to embed intelligence into every application, every API. Okay? So think about it. As you think about building your API layer, building a new class of applications, if you're not going to actually embed intelligence in that layer, then you're going to actually be left behind. The third thing that I want to talk about is, what if you thought that your network ended on your four walls? That's what we typically do for those of us who are in the enterprise world. But in reality, what if the network actually extended everywhere? There were no four walls. The touch points, the interactions, all have moved to the edge. Now, you have to embed intelligence into every piece of the network. The way to embed the intelligence, of course, is by taking your enterprise capabilities through APIs. But those you have got to actually power and embed with AI. You will embed intelligence into your edge applications for better operations, for better customer interactions, and for security. So what I've tried to do over these kind of three things is to say that as you have embarked upon your API journey to create this kind of digital world in which many more forms of interactions can happen with you, if you ignore the world of AI, you are actually going to be building to the world of yesterday as opposed to the world of tomorrow. So instead of thinking about, oh, the best I can do is to actually just connect my mobile app to my backend system, you really have to think about how do you make that connection to be smart, intelligent, and secure. So just as an example, we provide you with a product called Apigee Edge that enables you to kind of build up those APIs. And one of the things that we are doing is we are applying machine intelligence so that as you expose your APIs through Apigee, machine intelligence can actually help you detect when the interactions that are coming in are legitimate and when they are not. But you have got to kind of think through every interaction that's going on and seeing how you can actually leverage that power for better interactions and better security. So what I'm going to do is I'm going to call Jason Smith here, who has been working in this area of AI and API for a long time, and he's going to kind of walk you through what they're doing at Armark Bio, and then I'll come back and conclude. Welcome, Jason.
Thank you. Thank you, Anant. So I'm the co-founder and CEO of Armark Bio, and what we've set out to do with artificial intelligence is to leverage AI to help reduce the inefficiencies in which life science companies, for example, pharmaceutical companies, can partner with various researchers, clinical partners, and academic institutions based on the various stages of their drugs going through development, and ultimately anyone in the healthcare market. So where we're at, we've designed the blueprint for really transforming this global healthcare data into business intelligence. And this is really important for what we want to solve that's different than what everyone else has tried to do before. Because today, it's all been about having data scientists attack the problem who do not speak the language of the business, or you have business strategists saying, we need these type of people, and the data scientists don't understand what that fundamentally means to go extract that from all the global healthcare data out there. So the first thing we knew we had to do when we started this project about 2 years ago was we had to break down the barriers. We could build the coolest platform in the world, but if we couldn't consistently get data in there, it meant nothing. Then when we go to our customers, if we couldn't get their data into our platform, it meant nothing, because the unique value that we want to solve was that ability to translate between data and the business needs in real time. So our approach that we've started to go after was, how do we create a platform and then create APIs around each one of these tiny little bits so we can slowly, over the few years, build up a very large platform of microservices that we can leverage independently of each other based on different customer needs. So I think the best way to walk through this is I'll actually walk you guys through an example of a customer problem that we've recently solved. So a customer, a large pharmaceutical company came to us and said, look, we've got all this clinical data internally. We have all this ongoing R&D data going internally. We also have we have all the global health data you guys have. What we don't understand how to do is to align that in real time with who we should be partnering with. So we want to go to understand that if we're going to roll out a leukemia drug or we're going to roll out a multiple sclerosis drug, there's certain places in the world where these patients are highly populated. There's certain places in the world where their competition's already there. And there's certain places where their drug is going to have higher efficacy treating certain types of patients than not. They came to us to say, help us understand how to pull this data in, help us to understand what this data really means so we can go out and create deeper engagement strategies. And then third, how do we learn from it? How do we get feedback? You know, having RMark go in and survey their people in the field saying, was that a good recommendation? Did you like the person we recommended? That aligned? That's not going to work. So we knew right away we had to build in some mechanism to receive data and learning model and learning information back from our customers in real time who's actually out in the field. So when we started engaging this, we have our global health data that we pull in from every night from all over the world. We quickly realized that these pharmaceutical companies, despite being inside the four walls, actually have the exact same problem where their data is highly siloed. So you have omics data. So this is this is genetics, genomics, proteomics. People who are actually running the real science at the fundamental target level. You actually have the internal drug data, all their data through the FDA process, what they went through, the reports they cited, everything of that nature. They have practitioner databases, that what's happening in the industry. I have databases from IMS and others about what practitioners are actually doing and who they're targeting and who they're helping, but that sits completely isolated. Again, insurance data, and then they have research data. They have teams of people going out there and pulling in all this global healthcare data, but it's sitting siloed, and any of the machine learning and any of the analytics on this is completely separate from all these other groups. So in our conversations, we quickly found that data was really problematic for them. First, they have the three V's. You know, they just cannot handle the size and the change in which the data comes in. Then, based on those silos, how do they even exchange it? How do they share it? What do they want to do with it? They're not even sure what questions to ask. So they had no really idea how to draw insights across all these different data silos. And then once you have that, how do you translate that in real time to, I need a team to go to Washington State and find these 5 practitioners and engage with them because we need their clinical studies. And then most importantly, AI was problematic. We found great data scientists internally, but were really isolated to their specialty. So they understood omics. They understood, how to parse a grant paper. They understood how to apply NLP to a PubMed document on scale, but they didn't quite know how to translate that skill set to other data sets and other teams within the organization. And fundamentally, they were spending a lot of time and money doing very large-scale partnerships to try to solve this problem. And they were, at the end of the day, missed consequences. When you have trouble with the data, you have trouble with AI, we're having missed consequences. They're missing opportunities. They're spending a lot of time and money. And most importantly, by the time they get done with one subset, they were, of analysis, they had to go back and do it all over again. So our approach was, okay, we can apply artificial intelligence to solve a lot of this. And Anant took us on a nice game journey. This is going to be a little drier. This is going to be how we actually took the approach with them and how we leveraged some of the Apogee systems and then ultimately some of the Google technologies for this. So the first thing we knew we had to do on scale and build microservices around and create an API that we could reuse every single time to get this data was to ingest all this global healthcare data every single night, normalize it, and prep it for future analysis. Then once we had that, we had to start building learning models. We'll talk about this a little bit later, but we leveraged TensorFlow, we leveraged some internal algorithms that we've developed for our deep learning platform. We have to start taking this data in and letting the system understand what it is and learn. Next, we had to get our customer data. Now, this is where the real challenge was. As I discussed, there's multiple silos across multiple business and technology divisions. There's also just silos within the technology. Very often when you go into very large-scale enterprises that have been around for 80 years, you're going to have data systems that aren't readily available. It's not all going to be a node, a node database, or it's not going to be up in data store or Couchbase in JSON, which is really nice and easy. It's going to be something a little gnarly that you got to figure out what I actually need to get out of here and how do I even access the systems behind IT firewalls in a highly regulated system. And then ultimately, as a business, this is great, we can do this one time. We have to figure out how to create a platform that I can open up to not only ourselves for our applications, but we can't build every application in the world for every customer. We want them eventually to be empowered to take our APIs and take our platform and build their own applications, integrate it deeper at different points within the tools they use. So we're not the ones always doing it. So the first one was store and gather, or gather and store actually. So for this, we went around, we created a series of microservices using the Apogee platform for our APIs using Edge that talk to these individual behind the scenes data sources. So we were able to start pulling in the data, ingesting it, understanding it. For us, we use Dataproc just for the volume. I don't know how many of you here have used that before. We love it. We're huge fans of it, coming over from Spark and not having to manage all that ourselves. And then we've recently started engaging with Cloud Functions, where that's been helping a lot with just the onset scale of data, because customers are constantly updating. They have data that's changing. They're running hundreds and thousands of experiments a month at times. They have people in the constantly in the field learning new things. And we have to ingest all that in real time, plus all the global health data. And then storage. Where do we store this data? For this particular project, we leverage Cloud Store and Data Store because of the nature for the data. It made the most sense for how we were going to post-process it for our platform. So then next after this, we have the data in there. We start looking at what are the models. So we're big fans of TensorFlow. A lot of our core matrix algorithms run. So TensorFlow is a nice alignment with where we were kind of headed with some SVD and other techniques we were leveraging. And then just some of the natural language processing. We do still have to pull out key concepts, keywords, sentiment. We know from pulling in from Salesforce data in real time, if someone's out in the field and spoke to a doctor and they hear about these new patients they have with a rare disease, we can ingest that in real time, flag that, and push that up so someone in the business team can make a real-time decision off of that information. And then how do we put services around it? So if I walked into my customers and said, here's all the data and here's 42 different microservices and 50 APIs, that's not going to solve it. We had to bundle this up into API packages that they could use and they could access and they felt were secure, most importantly, because at the end of all this, we're in a highly regulated industry that requires, if nothing else, discretion and security first and foremost. So we built 3 primary services for our customer on this particular project on top of our platform. One was the real-time recommendations. So this is our learning process that understands who to recommend to the people in the field. So for example, if you're a top 10 pharmaceutical company, you have anywhere between 500 and 2,000 people you employ that go out all around the world. Their entire job is to find people to partner with, either doctors, either academic researchers, maybe more strategic as an entire institution. This is all they do. And it's a very manual labor intensive. This service bifurcates that manual process for them to a large degree, where we can give them real-time recommendations about what's happening in the field that they're in, a therapeutic area in a regional location, that aligns with their global business strategies. Learning and feedback. So Anant made a great point, and we couldn't agree more. None of this matters if it's all push if you don't start pulling and letting the data reinforce and train our models for us, not from instant thumbs up, thumbs down. It's got to be deeper than that. So we need to look at everything from when we integrate with Salesforce, we integrate with Viva, we integrate with a myriad of applications our customers, users touch every single day, and their employees touch every single day. We need to bring all that in and automatically continue to train our models such that we can leverage this by the real-time recommendations and by the clinical insights service, which normally we'd never talk to each other. Those services never talk to each other. But because we're getting that constant feedback from them. We're giving that constant, hey, I like this person, I don't like this person, but we're not asking them that. We're able to interpret that. We can provide that through our APIs back to the real-time recommendations, back to our clinical insights model, through the APIs, and now we're training 3 models in parallel through this platform. And then ultimately, Edge. Edge is the way we push it out. So as I mentioned earlier, Edge provided us with the fundamental infrastructure, the security, and the deployment stability that we needed from Apogee to allow our customers to feel safe, embed this API into some of their existing applications. In this particular case, we actually built a one-off custom app for them on top of our APIs. They embedded it in Salesforce and another proprietary tool they had in-house. So now, all through Edge, we have our app using these APIs that their employees are using, and all these other third-party applications are now accessing it through the Edge platform. So essentially, we set out to solve a fairly large problem in this space, and we think we think we're headed in the right direction, and it ultimately comes down to putting lots of intelligence behind every little piece along the way of the pipeline and exposing that through APIs such that we don't have to solve all the problems today. I don't have to have every data source integrated today. I don't have to have every learning model figured out today. I don't have to have every need of my customer figured out today. I can stitch and build these as I go. I can modify my models. I can modify my ingest. And done correctly, I don't have to modify a lot of my interfaces. And when I do, I've got Edge to help me migrate my customers from my internal platform. So we don't just use Edge for our customers. We actually use this for all of our internal microservices all the way through the platform, which now is somewhere in the neighborhood of about 25 different microservices that we just consume internally long before we even get to our customer. Thank you.
Great. Hey, thank you. This thing is heavy if it is not clipped in. Thank you so much. Hey. Okay, so what we have done is we have kind of, I talked a bit about kind of this advancement of AI and how it's gone from siloed applications to being democratized through APIs. We talked about how if you are embarking on an API journey by itself, you got to kind of think about AI as powering all of the interactions that are enabled by APIs. And then Jason talked through a wonderful set of examples of how in the area that he's in, APIs enable better AI, and then AI enables better APIs, and then there's this kind of feedback loop that's going on. And for those of you who are kind of thinking through live example of AI being applied, just look at the 2 blue screens on the left and the right, and there's nobody sitting out there transcribing. This is all going on by speech-to-text translations and others that are going on. So this is the fundamental point that we have tried to make in this thing. But I want to just step back a bit and say that if you really want to embark on an AI and an API-driven journey, technology will be easy. The reason technology is easy is because there are enough advancements happening and they are being released out in the wild for you to actually make use of. What you all have to think through is the people aspect of it. Other day I read something which said, oh, every doctor will have to become a data scientist. I said, what the heck is going on here, right? And then tons of people did thumbs up on it. Wow, sounded really, really interesting. Every doctor, the doctor barely has time to look after you. Do you think that she has time to actually now become a data scientist? That's not going to happen. But what's really going to happen is that you have to think through how your developers start leveraging the work of data scientists. You've got to think about how you're going to disaggregate your machine intelligence and AI organizations and scatter them into the rest of your organization. Ken Rudin, who was the CTO for Zynga before he went to Facebook, Ken Rudin said that he actually took his analytics and intelligence team and broke it apart and embedded it into every team that was doing was building games because it was easy for that team to come together, but it was very difficult for the developers to actually think about data and intelligence. So as you think about the role of AI, as you think about the impact of AI and APIs and the duality of it, think about some of the organizational structures that are fundamentally important. But the most important thing for you is the theme that I always like to say is we have, in the world of APIs, we used to say adapt or die. Sounds dangerous. I say adopt AI or die. So thank you very much, folks. And we have got some time for questions, if you all have. And Jason, come on up, and let's see if there are any questions. Otherwise, we'll be on our way. Going once, twice, thrice. Please, okay, can you either use a mic or all of you wait for my... okay, go ahead and say the question and I'll... Repeat it.
Yeah, so the question was, how do we monetize our business and what's our engagement model with our clients? So we have it's essentially a upfront license fee and an ongoing monthly fee for insights and services. Traditionally, think of it as an enterprise SaaS as our primary right now. Over time, we'll have lower costs for smaller companies. We're primarily focused on larger players now. So our pharmaceutical partners, our partner with groups like University of Chicago and some other investment firms. It's because that's really the hands-on piece right now that we're involved with.
Okay. Okay, great, guys. Hey, thank you very, very much. And we are around for some time in case you guys want to have questions. But otherwise, thank you very much.
Thank you very much.
Okay? Great.